So now let's talk about continuity of a function of two variables. Again, the idea for this is very similar to the idea for a function of a single variable. And so I'm just going to write the definition of this. This is a function f of two variables is continuous at a point x naught, y naught, if, well, the limit exists. The limit, as I approach my point, exists. And even more than that, it's required to be the same thing as evaluating my function. So let's talk about, so what's nice is that a lot of our same results from before hold true now. And so in particular, one thing we want to note is that for polynomial and rational functions are continuous on their domains. So this was true for functions of a single variable, but it's also true now for functions of two variables. And so let's look at an example here where we're finding where a function is continuous. So discuss the continuity of each function. So the first one we're going to look at is the function f of xy is x minus 2y over x squared plus y squared. So remember that this is a rational function. It's a polynomial over a polynomial, so that means that it's continuous at every point in its domain. So now we just need to find the domain of this function, which we've done previously. Right here I'm dividing, so I need to make sure that the denominator is not 0. But this equation here corresponds to just a single point, 0, 0. So this function is continuous at every single point but 0, 0. So it's continuous at every point in the xy plane except the point 0, 0. So let's look at one more of these. Part B. Let's say my function g is going to be the function 2 over y minus x squared. Again, this is still a rational function, which I know is, I said before, it's continuous on its domain. So I just have to find the domain here. I'm dividing, so again the denominator cannot be 0. So this function, it's continuous everywhere except points on y minus x squared equals 0, Or you could say y equals x squared. So when it comes to these rational functions, if you're asked to discuss the continuity, all you need to do is look for its domain, and that'll tell you where it's continuous.